we are going to start doing some things. Well, last week we kind of did a little bit with percentages, but we're going to start talking about some things that I think, even if you're not going to do any more math your entire college career or whatever, you should probably understand these things, right? I was saying to somebody earlier, if you don't know how to graph parabolas a year from now, it's probably not going to be life or death, right? This won't be life or death either, but it's something that money's a big issue for a lot of people, right? And it's one of those things where you got to understand how money can either work for you or how money can be a detriment if you're borrowing money all the time. Okay? So we're going to talk about, first things first, we're going to talk about is this thing called simple interest. Okay, what's interest? Okay, so Jeremy says it's money that you pay on top of what you borrow. That is one definition of interest. That's kind of the one that you don't want to have because you're borrowing money, right? But the other definition of interest is money that you make on top of money that you've given to someone. Most of the time it's a bank, right? Unless you're some sort of loan shark yourself and giving out money to people, right? But if you have money in your checking account, although these days the checking account rates are 0.1% or something ridiculously low. But as far as earning money, you can earn simple interest in a number of different ways. Okay, and we'll talk about the other kind of interest, which is even better in a little bit. Hey, Robert. Okay, so I've already written a couple of vocabulary words down. Actually, first things first, let me hand out the formula sheet that you can use for everything for the rest of the year. You can write on this all you want, but what you won't be able to I will give out a new one of these during the test. So you can't put more stuff on it and use it during the test. But hand this around. Actually, can I grab one as well? On the formula sheet, okay, there are a lot of formulas for all the different stuff that we're going to start with tonight. On the back, there's a little table. No, Tony, don't worry. This is actually good news because all you need to do is know when to use these formulas and how to plug everything into your calculator. It does take a little practice, but this is not something you have to memorize, which is great. The only formulas you have to memorize in here, there's really only two of them. Quadratic formula, which we already did, and the formula to find the vertex of a parabola, negative b over 2a, which is part of the quadratic formula, so you've already got it memorized. Anyway, these ones are the first top here is on financial management, which is what we're going to talk about, and in particular equations that do involve interest. Okay, so let's take a look at the vocabulary here. Okay, everybody have a formula sheet now? Good. All right. So for the vocabulary, the first one here is the principal. Okay, and it's spelled AL, like the principal of your school, although it's not the principal of your school. It's the principal in money terms. It's the amount that you start with. Okay, it's the amount of money that you either invest, or if you're borrowing money, that's how much you're borrowing. Okay, that's called the principal. Okay. The rate is actually a percent. It's actually written as a decimal, but we generally refer to it as a percent or a decimal. When it's in the formulas, we write it as a decimal. We'll do lots of examples on this. This is the per year rate. You generally don't talk about a rate per week or per month. You talk about a rate per year. Okay, and you don't talk about a rate per decade. It's a rate per year. Okay, that we'll do that. Okay, rate per year. And we're going to generally write it in these formulas as a decimal. The time is the number of years that you're investing this. Okay, so question. If you were to invest something for 1 month, how many years would that be? Not 0.012, although you're right idea. No, 1 over 12, whatever that is. Do that on your calculators. 1 divided by 12. Anybody need a calculator today? Go. Dominic. Oh. All right. Anybody else need a calculator? Okay. So 1 divided by 12 would be the rate. It would be the time if you had 1 month, because it's 1/12 of a year. Okay. So it's in the number of years. Okay. So when we get to time, we'll talk about that. Okay. I know some people are still writing these down. let me get the next thing. The first formula on your sheet, okay, is called simple interest, okay? And the formula says I equals PRT, like that. Okay? Hey, Duan, how you doing? Okay, PRT. Well, we actually know what all those things mean right now. Well, except for I. We haven't talked about I yet. Okay? The P is just the principal. The R is the rate. And the time is T. This stands for the interest you get. Okay? So this is actually the interest, which I guess is another vocabulary word. Okay? That's either the amount that you spend on top of or underneath, or you get because you're lending money to someone. Okay? And that's really what a bank loan or a bank is, right? You're lending money to the bank, right? Now, instead of paying, them paying you a nice big rate, they pay you a nice tiny rate because they're a big bank and they can do that. It's unfortunate. But I equals interest equals principal times rate times time, and it's right on your sheet, and you can use this sheet for your tests and your homework and whatever. Okay? Can I erase these? People still writing? OK. All right. So let's do a couple of quick examples. This is not hard stuff right now. OK? I equals PRT. Bob deposits $1,700. $1,700 into an account that earns 2% simple interest. Now, by the way, I'm reading this and not writing all these words down. If you want to go look at the words, because this really is a word problem, right? I'm just writing down the important parts. Okay, Bob deposits $1,700 in an account earning 2% simple interest. Simple interest. Okay. How much interest will he earn in 3 years? Time equals 3 years. How much interest? So I want to find the interest. Okay? This is not that tricky, I hope. I'm not giving you all the different parts, right? I equals principal times the rate times the time. It's the interest. Principal is how much? $1,700. The rate is how much? 0.02. Good. 0.02 is the interest rate. And the time is, of course, 3 years. So 3. Okay? Do that on your calculator and tell me what you come up with.
Would you take the 3 years and put it in months? Or
OK. What did we say time was? In years. So it's always in years. Okay? If it was 1 month, you'd put 1/12, because then it's in a year. 1/12 of a year is a month.
I'm saying, like, you know how, like when you get a car loan or whatever,
yeah.
They give it to you in months.
Ah, good question.
Hey, you have 72 months to pay this off at this interest rate, and that's what
They will tell you the interest rate for yearly interest rate, and then they'll charge you in monthly installments, which we'll get to. We'll totally get to monthly installments, but very good question. Yeah, if you ever go to one of those places in, anybody stationed in Norfolk? Yeah, you know how many different loan sharks there are, and you drive down the main strip in Norfolk, and there's car dealership here, car dealership here. It's got some sailor with his car keys, and he's all excited, and there's some sports car behind him, right? Well, they are generally going to try to make you think you're paying a lot less than you really are. So they'll tell you your rates. They'll always try to tell you your monthly instead of the whole amount, and you got to be really careful. But when you understand some of this stuff, you'll start to be able to talk back to them honestly and know what you're talking about, because you know what you're doing. Anyway, $102 simple interest per year. Okay? So in 3 years, or sorry, not per year, $102 in 3 years. Okay? So over 3 years, you put $1,700 in the bank, 2% interest. You end up with $1,700 plus $102 at the end. Okay? Not that much. Really. Yeah, 2% interest is not so good. And this is what happens in your bank these days. It's not even 0.2, it's 0.02%. I mean, it's ridiculous in savings accounts. So, oh well. OK. Find the interest on a $2,000 loan at 5% after 1 year. $2,000 loan. $2,000 loan, 5%. for 1 year. Nope, I lied. I'm not multiplying correctly. How about 100? Thank you. I was thinking it was divided by for some reason. $100. So it's $100, right? $2,000 loan, 5% 1 year. It's actually not too bad. So anybody sign up for that? What is it? That loan, that 10% loan or whatever? The SDB, is that the one? Yeah, that's a great deal. If you're here for a year, right? I mean, people like not here for like 0 time, can't really benefit as much. But if you're here for a whole year, you can put up to $10,000 into that, right? Right? If you put it all in at once, and you do have to get some special letter signed if you want to do that, but if you put it all in at once, how much money are you going to make by the end of your deployment? It's simple interest, right? It's a 10% interest for 1 year, 10% interest for 1 year on $10,000. 10% and 1 year. Well, we can do that. Principal is 10,000. It's actually a pretty easy calculation. Times 0.1 times 1, which is $1,000. That's like an extra $1,000 bonus. You can call that your yearly bonus in the Navy. They just give it to you. Yeah.
I have a question. Why would you do the time for 1 year if it just doesn't make sense to me.
Why would I do that?
It's going to come out the same, right? So you could just leave out the time if it's only 1 year?
What do you mean?
So you get...
Oh, because I'm just doing everything in the formula. Okay. You want to do all of it. You're right. It's gonna, if you leave out the 1, it's gonna, but it doesn't really matter. 1 year is just for 1 year, okay. Right? If somehow you got extended to 2 years, you'd put a 2 in there and it'd be $2,000. You know, okay? So yeah. We could, later in the class, we'll talk about what happens while you're here if you are putting, let's say you put $1,000 a month in there. Well, by the end, how much will you have? You can actually figure that out because you put a monthly installment into it as well. And actually, if you started out with 0 and put $1,000 a month, you wouldn't quite make $1,000 by the end. But it still would be more than what you get for not doing anything with your money. Okay. All right, questions on this stuff? Not too bad. OK, so that's how we find the interest rate. Sometimes, however, you want to find what your money's going to be worth after some amount of time. Or, like your car loan, how much you're paying total after some amount of time. Right? That's what you'd be wanting to know. Exactly. Yeah. In fact, if you ever buy a car from a dealer, ask him straight up and say, calculate for me how much I'm going to pay over the 5-year loan you're trying to give me, or the 6-year loan. And all of a sudden, your $22,000 car will turn into a $37,000 car, you know? So it's ridiculous. OK, so when we want to find the future value of something, we just call it the future value. OK? The future value. In this case, the letter for future value, it's another one of these ones that's perfectly named. It's called the A, right? It's actually called the annuity, I believe. But anyway, the future value here we're going to call A in this case. OK? And that's the total amount to be repaid on a loan, or the total amount you'd get on investing a certain amount of money. OK? So this is we'll call it A. It's the total amount to be repaid. Repaid on a loan, which means it's principal plus the interest. Okay? So what it is, it's actually your principal plus the amount of interest which we have, P times R times T, like this. But that's not how you're going to see it on your formula sheet, because what you're going to do is you're going to factor out a P. Right? And you're going to take a P out of both of those, and you're going to make principal times 1 plus the rate times the time. And that gives you your annual, or sorry, that gives you your future value. OK? Here's an example. OK, let me write this up here. Just right there. Okay. in this case, okay, let's say we have a loan of $7,000. Okay, a loan of $7,000 at 4.5% interest. That's a 4. 4.5% interest for 9 months. Not a full year. For 9 months. Okay, and we want to find the future value. Find the future value. Okay, I'll just rewrite this up here. Future value equals the principal times 1 plus the rate times the time. That. Okay, this is plug and chug basically. Principal is $7,000 times 1 plus the rate in this case is 4.5. 4.5, oops, sorry, not 4.5. What is it going to be? 0.045, right? Because we have to do it in a decimal. Times, and how much time are we going to put?
1/3.
We're going to put 9 over 12, right, which is 0.75. So you're right. OK. I'll write it as 9 over 12, because that's how many years you're doing this for. 3/4 of a year. Right? OK, here's how you do this in your calculator. You can't do it all at once. This is why we practice these order of operations. The first thing you have to do is the rate times the time. So you do 0.045 times 9 divided by 12. Okay, and you get some number. Once you hit equals, then you hit plus 1. And then hit equals again. And then do times at 7,000. You can do it in the other way if you use your parentheses properly. And did you guys get $7,236.25? And 25 cents. For anything that comes out in dollars, you can round to the nearest cent, even though this one happens to come out evenly, or come out in cents. Sometimes it'll come out more. Just round to the nearest cent. Okay? In fact, you know the IRS doesn't even care about the number of cents? When you're doing all your calculations, you can skip the cents part. Just do it in full dollar amounts. It all works out. Do they round up? Sometimes they round up. Sometimes they round. It doesn't really. When you type it in, it rounds up. Oh, yeah. That doesn't surprise me. OK, so that's the future value. OK, all right. Question. Some of you guys might have friends like this. Let's say you have a friend who's not here. Let's say your friend Amy, OK, says, I'll lend you $2,000. Amy, if you're watching this, you're lending people $2,000. OK? $2,000 from Amy. OK. And you agree to pay Amy $2,225. $2,225 in 3 months. OK? What interest rate is Amy charging you? OK. This one, you have to do a little bit of algebra to figure this out. Because we are given what? We are given the, what are we first given? The amount you're borrowing, which is principal. You're also given the amount, right, or the future value, right? You're given the future value. You're also given the time, right? What aren't you given? You're not given the interest rate because that's what you're trying to find out. Now, a bunch of you will try to use the wrong formula. You'll try to use the first formula on this because it says interest, right? But you can't quite do that. Okay, because what are you missing from the first formula? Let's see. Principal, rate, and time. I guess you're missing the rate, right? So you don't actually know the, well, yeah, you're missing the, sorry. You're not given I. You're looking for R. I lied. You're actually looking for the interest rate, R, which you're not given in the first formula. OK, let's look at the second formula here. OK, this is what we're looking for. OK, we have that the formula says the future value equals the principal times 1 plus the rate times the time. OK, we're going to eventually get the rate, but let's plug everything else in. You can either do the algebra first, or you can do the rate, or you can do the plug in first. Doesn't really matter to me. Let's plug in first. The future value, 2225. The principal, 2,000. 1 plus the rate we don't know, so we have to leave it as R. And then the time is going to be what? 3/12, right? 3/12. Okay, or you could put 1/4, or you could put 0.25. It doesn't actually matter. But we have to do a little algebra to figure this out now. Anybody want to tell me what the first thing we have to do here is? You could distribute. You could distribute the 2,000 here and here, but there's an easier thing to do. I like that. I like the answer I just heard. Isn't this being multiplied by this? What's the inverse operation to multiplication? Division. So we divide both sides by 2,000. 2,000. 2,000. Isn't that going to get rid of the 2,000 on this side? It is. So and this is going to be 2,225 divided by 2,000, which you can do on your calculator. 2,225 divided by 2,000. 1.1125. So you're left with, I'll write it over here, 1.1125 equals 1 plus R times 3/12. OK, what's the next thing that we want to get rid of here? The 1. That's easy. We subtract 1 from both sides. And that's actually easy to do over here because it's 1 there. So it's just going to be 0.1125 equals R times 3/12. OK, or let's just make that in 1/4. We'll just reduce that to 1/4. Why not? 1/4. Now, a bunch of you did not know how to get rid of this on the quiz last week. Right? If this is being multiplied by 1/4, you could do what to both sides? Divide by 1/4. Or it's actually dividing by 1/4 is the same as multiplying by 4. So if we multiply by 4 on this side and 4 on this side, OK, 4 and 4, what do we get? The 4's drop out here, and we get 4 times 0.1125. Right? Which is 4.45 equals the rate. Wait, did I do something wrong? I must have.
There's no 0.45.
How about?
0.45.
Yeah, you're right. Is it just 0.45? Hang on.
It is.
0.1125. Yeah, that's right. Times 4. Yeah, 0.45. 0.45 equals the rate, which means how much interest is Amy charging you? Do it by 2. 45% interest. OK? So now we know what Amy's spending, what she's using to pay for all that fun she's having in Ethiopia. Right? Because she's charging you 45% interest. Okay? This is the kind of thing that you need to be wary of whenever you get a loan. Okay? All right. Let's try another one where we have to do the same thing with the algebra, but maybe for something different. Any questions on this one? How I actually did this? Step by step by step. Plug in what you know, and then solve for what you don't know. Okay? We could put another formula on your formula sheet that gives you the rate in algebra terms, but I'm not going to, because you got it there and you can do algebra. Okay? I know that's mean, but that's the way it goes. All right. OK, let's try another one. Let's say we want to calculate the present value of something. OK? So if here's the question. Okay? It's no longer Amy on there. Okay. All right. You're deploying for 9 months, let's say. Okay? Deployed for 9 months. Okay? At the end, you want to have $5,000. Hey, Sharif. You want to have $5,000 at the end. Okay? At the end, because you're going to buy a hot tub or something. Right? I want a hot tub too, but those of us who live in apartments probably can't go build a hot tub outside our apartment. Okay, you want to have $5,000. How much money do you need to put away, okay, in this SDP that we talked about? How much money in the SDP, what does that stand for? Savings Deposit Program? Yeah, Savings Deposit Program at 10% interest. At 10% interest, so you have $5,000 at the end of your 9 months. $5,000 at the end of the deployment. Okay? Question mark. Let's look at what we're given again. What's the 9 months going to tell us? Time, T. What's the $5,000 at the end going to tell you? That's the future value, right? A. Okay. What's the 10%, of course? The rate. What are we missing? What are we missing? The principal. So the principal is what we want. Okay, so you look at all these things and you say, I know a formula that relates the future value to the principal using the interest and the time. And you write it down and you say, future value equals the principal times 1 plus the rate times the time. Okay. And now you're solving for principal. Let's do that part before we type any numbers in. How do I get rid of the 1 plus r times t, which is being multiplied by the principal? Divide by it. You divide by the whole thing. Divide by 1 plus rt, and you divide this side by 1 plus the rate times the time. Okay? I'm going to move this over to here. You are left with, actually I'm going to move it up to here. You are left with, okay, the principal equals the future value divided by 1 plus the rate times the time. Okay. Now you can plug in some of the values. The future value is $5,000. 1 plus the rate, which is 0.1 for 10%. And the time now is what? How much time do we have this for? Yeah, what is it, Ben? 3/4 or 9/12 if you're thinking about it in terms of years. I normally leave it like that. You can do 3/4 if you want. Okay? And then you just do this in your calculator. Let's do this all at once in our calculator. 5,000 divided by parentheses, open parentheses, because we have to divide by this whole thing. Okay, open parentheses. Try it on your calculator. 5,000 divided by, and then the open parentheses. And then 1 plus, you don't need the parentheses in here, but I guess you do if you're going to, no, you probably don't actually, but I'm going to put them in anyway. Open parentheses again, 0.1, close parentheses, times, open parentheses, 9 divided by 12, close parentheses. Let's try it again. 4651.16. Is that what we got? OK, let's try it again. Yeah, let's try it again. 5,000 divided by. I'll do it without all the extra parentheses.
Okay, there it is.
5,000 divided by. You need at least one parenthesis. You have to do an open parenthesis. Because look, if you don't, you can't do 5,000 divided by this without doing this part first.
So it's 5,000 parentheses 1 plus
5,000 divided by.
Yeah,
Okay, good. Parentheses,
Okay, there you go.
1 plus 0.1 times 9 divided by 12.
Then your closure parenthesis, right?
Yes, although your calculator doesn't have to have the closure, but yeah, the closure parentheses works. $4,651.16. Still not what you guys
There's
said?
extra numbers behind it.
Forget about those,
Oh, okay.
because you round. Because really, you can't go to the whoever you give the money to, the J1, and say, I want to put 4,651.1652783. You can't do that, right?
Yeah.
You have to put the number like in cents, because they don't take anything less than that. Okay. Okay. Questions on that? Okay. Is anybody in here a homeowner? I think I asked this the other day. Anybody in here a homeowner? Yeah. Do you ever hear of when you're trying to refinance your home, or even when you get a loan to begin with? Hey guys, who doesn't have the formula sheet? 1, 2. There you go. Oh, there's 2 right there actually. Okay, if you're a homeowner, sometimes when you refinance, they talk about paying points on a loan. Ever hear that? Yeah, we're about to find out what that actually means. Okay. You can pay points when you initially get a loan as well. Okay, here's what points are. So let me just start out with an example on this. A lender gives you, okay, or I should say loans you. This is no giving here. This is loaning you. Loans you $10,000. $10,000. Okay? If that lender only gives you, but only gives you $9,600. Okay? In other words, you're borrowing $10,000, but only getting $9,600 because you're paying the interest now. You pay the interest up front. That's what points really means. Okay? And so, well, that's not what points mean. That's what we call a discounted loan. It ends up being, we also, when we're doing mortgages, we call it points. This is called a discounted loan. Okay? The $400 the $400 here, when you subtract these away that you pay, okay, that's called the discount. Okay, this is a $400 discount. All right. Let's actually do an example of this. This is, well, I guess this should, let's do this example. Well, let's do a slightly different example, because this one we didn't use the interest rate and all that. Okay? As an example, okay, let's say you borrow forget about those numbers up there. You're borrowing $8,000. Okay? You're borrowing. Okay? On a 7% discounted loan for 1 year. Okay? What is the discount? That's question number 1. Okay, well, this is actually not too bad. This is saying, well, what's the interest that you would pay on $8,000 for 1 year? That's the first, what's that? 500, you say, oh yeah, 500, because you already did the calculation. The discount is 7% of 8,000, so it's interest, right, equals the principal times the rate times the time. Principal's 8,000. The rate is 0.07, and the time is 1 year. And you're right, it's $560, because you just do that out. I bet the way Ben did that so quickly was because 8 times 7. Is that about right? All right. 8 times 7 is 56. All the zeros in there make it end up being $560. So that's the discount. Okay? So next question. How much money do you walk out with? even though you're borrowing $8,000, you're paying the interest now. So you walk out with how much? 2. Walk out with 8,000 minus 560, which is $7,440. That's how much you're walking. That's how much you're actually leaving the place with, because you already paid the interest. Okay? But the question is, what's the actual interest rate? Actual interest rate. What does this mean? You still have to pay back the $7,440. You're going to do it over 1 year. Okay? So if we know that you've paid $560, but you're only getting $7,440, interest equals the principal times the rate times the time. Really, what's happening is the interest, we already know, is $560. Okay? The principal is $7,440, because that's how much you walk out with. We don't know the rate yet, but we know that it's for 1 year. To solve for the rate, it's actually pretty easy. Just divide both sides by 7,440. Okay? And what do you get? This means the rate equals 0.0753, or 7.53%, which is actually higher than the discount rate because you don't actually get the full amount that you borrowed. You really only get the lower amount because you paid the interest up front.
So in the long run, you're actually paying back more money.
Yeah, well, in the long run, you have to pay. No, not really. You're still, it's as if you borrowed $8,000, but you don't get the $8,000 up front, right? If you got the $8,000 up front and paid $560 interest over that time, it would be 7%. But really, you're paying the $560, but you only get in your greedy little hands $7,440. That's why it's, not necessarily. That's why we want to figure out what the real percent is, just in case you have a question, just in case you want to figure, you want to know that discounting is not always the best idea. Okay? There are times when we talk about points later, we'll talk about when it's a good idea to do this. Okay? When it's a good idea to do this. Let's do this. Let's take a break now, and then, because that was 40 straight minutes, and then come back at 10 of, if you could, 10 minutes. Next thing we're going to talk about is called compound interest. This is where you can really start to make the money. It's also where you can really start to pay out big if someone actually charges you a loan with compound interest, right? Like your mortgage. Okay? In compound interest, here's how it goes. Okay? Let's say that you invest $100 and somehow you get 10% interest per year. Okay? In some bank for 10 years. Okay? You invest $100, 10% interest for 10 years. Okay? After the first year, how much does the bank owe you? $10, right? So after the first year, after 1 year, the bank owes you $10. Well, guess what? For the next year, shouldn't you be getting interest on that $10? They owe it to you. You should get interest for the next year on that $10. Okay? So for the next year, they should pay interest on $110, not $100. Okay? This is called compound interest. Okay? It's interest on the interest. Okay? And this can get big in a pretty cool way. Okay? Watch what happens here. Okay? Year 1. Okay, I'm going to do a little table here. I'm going to do years. I'm going to do, actually, I'll just call it year here. And then the starting balance. Sorry, my pen's not so good. And then the ending balance. Okay. All right. In year one, okay, your starting balance was $1,000. At the end of the year, your final balance is 1,000 times 1 plus 0.10, which is $1,100. Okay, why did I get 1,000 times 1 plus 10? Well, this is your final value formula, right? Principal times 1 plus the rate times the time, and the time is 1 year. Rate is 0.1. Okay, so that's $1,100. Okay, let's look at year two. Okay, in year two, now you're starting with $1,100. Okay, what's that?
You change numbers around?
No, what did I do wrong?
Start with $100.
Oh, you're right. Yeah, we'll do it with 1,000.
Okay.
We did start in this case. You're right. So let's do it. $1,000, 10% for 10 years. After 1 year, it's $100. Let's say it's that way. Thank you, Dave. Okay. All right. So in year two, you're starting with $1,100. Okay. But now you've got your final value is $1,100 times 1 plus 0.10, or $1,210 at the end of the year. Okay. What this actually means is if we go back and use the original value, it's actually $1,000, the original, times 1 plus 0.10 squared. Because didn't we do 1.10 twice here? And we multiplied it by the original amount? It's basically what you did. You did the original amount times that value again, which is 1 plus 0.10 squared. After year three, you're now starting with $1,210, okay, which is the final value is 1,210 times 1 plus 0.10, which in this case is 1,331, which is also equal to 1,000 times 1 plus 0.10 cubed, because you're just multiplying by another 1 plus 0.10. And then finally, let's do one more. After the fourth year, okay, you start with 1,331, okay, and it's going to be 1,331 times 1 plus 0.10, which in this case equals 1464.10, which is the same as saying 1,000 times 1 plus 0.10 to the fourth. So you see how this works now. See the little pattern here? 1,000 times 1 plus 0.10 times the number of years. Ah, that's nice. Okay. This is how compound interest works. We're going to actually use that in our formula in a little bit. Okay. Well, why would the bank pay you every year? Why not after the first month? Right? People still writing these ones down? Some people are still writing them down. I'm going to just erase the top. Let's see. There's not much room here on this little board. We know what this one is right now. OK. So instead of doing every year, we could do every month. OK? So let's just do the same sort of thing here. I won't do that many months. But if we did after year one, same thing. Year, starting balance, and then ending balance. Same thing. Okay? After year one, you start with $1,000. But now it's not, you're getting, or sorry, after, this is not years anymore. This is now months. After 1 month, we can figure out how much interest the bank will owe us. Right? It's going to be 1,000 times times 1 plus 0.10 divided by 12, right? Because it's only 1 month's worth of interest. It's not 10% yet. It's 10% divided by 12 because it's 1 month's worth. Okay? After 2 years, okay, and by the way, this equals 1,008 and 33 cents after 1 month. Okay, so now you're starting with 1,008.33 on month number 2. Well, that equals 1,008.33 times 1 plus 0.10 divided by 12, okay, which equals, in this case, it's going to be 1,016 and 74 cents. But if we did the formula, it's multiplied by this again. So it's going to be equals really 1,000 times 1 plus 0.10 divided by 12 squared. Okay? And you keep going with that same pattern again. Okay?
So when will you know to divide versus the one on the bottom where we multiply? So if we have months, that pretty much tell us we need to divide?
Yeah, good question. When do you know you have to divide by something? This number here is going to be, it's going to be the rate divided by the, well, it's going to be, sorry, this is going to be the rate divided by the time. We'll see it in the formula in a little bit. So you'll always be dividing, but sometimes it's just going to be 1, not 1/12. You'll see when we get to it. That didn't help you.
Not at all.
Let's get to the formula, then you'll see when it is. How's that sound? Okay? All right. So let me show you what would happen after 3 years of this. This is every month. Okay, we're doing that. How many years is months? How many months is 3 years? 36 months. So we do ... all the way down to 36. Okay? Well, it turns out that we don't need all these starting values. We only need one starting value because we know it's going to be 1,000 times 1 plus 0.010 divided by 12, right? Raised to the number of years times, right?
Isn't that only 10%?
Isn't it what?
0.1.
Thank you, it is. I messed up that again. It's 0.10, okay? Times the number of, it's actually the number of years, which is 3, times the number of times per year, which is 12 in this case. So this is going to be 36 up here, because it's really going to be raised to 36. 1,000 times 1 plus 0.10 divided by 12 raised to the 36. Okay? And when you do that, you get $1,348.18. And you have to round a little bit there. Okay? Okay.
Where did you get the 3 from, sir?
That's the number of years.
It's 36 months.
It's 36 months. But that's 12 times per year, compounding is what we're calling it, once every month, times 3 years. Okay? We'll get to, you'll see it on the formula sheet in a minute, and you go, oh, I get it. Yeah, Duan.
Quick question for you.
Yeah.
On the first one,
Uh-huh.
when you got 1,008.33 cents.
Yes, this one.
I guess I'm doing something wrong, but I came up with 1,000
Did you
I
do,
switched to zero somewhere.
let's try this again. 1,000 times, open parentheses, 1 plus 0.1 divided by 12, end parentheses. Does that work out? Yeah. Yeah. Okay. Yep. Okay. So, and by the way, compounding it monthly like this is actually more, you're going to get more money than if you'd compounded it yearly. Why? Because you're paying the interest more often. Like you're paying the interest and getting interest on the interest more often. Because remember, compound interest is interest on interest. Which is pretty cool. Okay? All right. Now we'll get to the formula. Okay? Get to the formula itself. We've already kind of gone over it. You've seen the formula, but let's actually write it down. Okay. If you deposit P dollars, okay, at a rate R, and remember, R is a yearly rate. Don't forget that R is a yearly rate, okay? Subject to compound interest. In other words, you're getting compound interest, subject to compound interest. Compound interest, okay? Paid, oops, not pain. Oh, this is painful, I'm sure. Paid n times per year, okay? Then, after t years, your final value, A, is the following. Okay? Final value equals the principal times 1 plus the rate divided by the number of times per year raised to the number of times per year times the number of years. Is that on your formula sheet?
Yes.
It is. Okay. Yeah, if I had just thrown this up here, you would have gone, well, where'd that come from, right? But now at least you kind of see why, even though, you know. Not. So n is the number of times per year that you're getting this compounding. Okay? So in the months, it was how many times per year? 12 times per year. And up here, you got to do the number of years, or number of times per year times the number of years. That's where you get the raised to the power. This is the first one of many which have similar form to this. Okay? A bunch of other formulas on there that will have these kind of forms. Okay? When we talk about n, let's just get this down. If the word is annually, what's n going to be? It's going to be 1, right? Because you're doing it one time a year. If it's semi-annually, that's 2 times per year. Don't worry about biannually, because we'll try to use semi-annually. Okay? How about quarterly? 4 times per year. Okay, we already talked about monthly. 12 times per year. And then, of course, daily, 365. There will be a couple times, for whatever reason, I don't know if it's on the homework or what, sometimes they say use 360. I don't know why they think that that's 360 days in a year. Maybe it comes out, the numbers come out easier. But
Maybe
just,
they're using a 30-day month.
yeah, if they're using a 30-day month or something. But whatever it is, if it says 360, plug in 360 for n instead of 365. But normally we'll plug in 365. Technically, you should probably plug in 365.25 because of the leap years, right? But don't worry about that. OK. All right. Ready to try an example on this? Here's the example. Find the future value of $2,500. $2,500 invested at 3%. At 3%, that's a 3. Interest compounded quarterly. Quarterly for 5 years. Okay, you're trying to find the future value. That's what we're looking for, the future value, A.
What is n for again?
N is the number of times per year.
Okay.
The hardest part of these is getting your calculator to do the right thing. Especially when you know that this is going to be, you got to do the 4 times the 5 first, or in parentheses. Okay? You want to do this all together on the calculators?
Because I used 4% interest. That's why.
Ah, 3% interest, not 4% interest.
3%. See if I get the right answer.
I was done. I was getting done. It's a lot.
Did you guys in the back row get this one? Robert, did you get this one? No? Let's type it together in the calculator. First of all, did you get the numbers down in the right formula? Yeah, OK. Let's do it together. 2,500 times, open parentheses, 1 plus 0.03 divided by 4, close parentheses, caret, the little caret one, which is the raised to the power, another open parentheses, 4 times 5, close parentheses. Or you could just do 20 in your head, but either way, but you're going to need to do that.
So if you have that carrot, you can just put parentheses for. No, just do this. Just do 20th power right there.
Or to the 20th power. Doesn't matter. Yeah, that's fine. This is 20. You do 3 times 5, yeah. But you do that in parentheses.
I was messing up because I put the carrot. I put parentheses 3, close parentheses, open.
Oh, no, you can't do that. It's all one parentheses, right. Rob, did you get that number this time? OK, practice this one on your calculators. OK, practice this one on your calculators. OK, here's one more to do on your own. OK, $7,000, 4%. Now it is 4%, Michael. Compounded daily for 3 years. I'll write it down. Yeah, I'll write it down. Daily, compounded daily for 3 years. Okay, $7,000, 4% daily compounding, 3 years. 365. Did I round wrong? No. OK. 7,000 times. What's up, Tony? You're confused? OK. Are you confused on writing this stuff in the formula or the calculator? Yeah.
So I put that.
You got to put this one in parentheses, 1 parentheses. I wrote it like 2, but really this is.
I get to the.
If you're having trouble putting this in the calculator, just let me know and we can work on it. OK?
I do 365 times 3, which I can't do this, right? So then I'll do
Remember, it's all about order of operations. When things are in parentheses, that part has to, or when things are in an exponent, you have to do what's ever in that exponent before you do the exponent of the other thing. That's why I put the parentheses around those. Did you get the right answers, Tom? OK, let's try it again. Just bear with me. Ready? 7,000. 7,000.
Okay, 7,000.
You guys ready for this? 7,000 times.
7,000
Times.
times. I thought it was parentheses.
It is, but that means times.
Okay, parentheses.
Now parentheses. 1 plus.
Oh, okay, hold on. 1 plus 0.04, divide that by 365.
Yep. And parentheses.
Close, okay, close parentheses.
Yep.
Right?
Close parentheses.
Know what I just know?
Okay, hit the little caret button.
The carrot button, okay. That's
Okay.
what I'm missing.
And then do another open parentheses, because you got to do the other two numbers in parentheses. So open parentheses. 365 times 3, close parentheses, equals.
Yeah, see, I was confused on this carrot thing.
That's
what
okay.
it was.
If you're confused on that, that's okay, but now you know.
Okay, but now can you do 3 by 365 first?
Sure. If you want to do that first, go right ahead. 365 times 3 is 1,000 something. 365 times 3. 1,095.
Right, so then I would do everything out, and then I would put this 1,095 in parentheses.
You don't even need that in parentheses.
I don't need it in parentheses.
If it's one number, you don't need it in parentheses.
So that's what.
Yep.
But that gave me the wrong number.
What? 7,000 times, open parentheses, 1 plus 0.04 divided by 365, end parentheses, caret, 1095. Same answer. By the way, that's a huge number to raise something to. The nice thing is this is really close to 1. So if it wasn't, you'd be in big trouble. Your calculator would give you an error if you try to do another number besides that. Okay? All right. So is there some sort of a limit to how much compounding you can do? In other words, take a look at this. You don't have to do any of this out, but let's say there's $1,000, okay, 4% interest for 5 years, and we're going to compound it. If we compound it 0 times, okay, let's say you don't ever compound it, it's a simple interest, okay, we would get $1,200 out of that, okay, if you don't compound it at all. If, however, you compound it annually, okay, you could do the calculation. Annually would be 1 time per year times 5 years. You could plug this in. You'd get $1,216.65. Instead, if you said, no, the bank should pay me every month, right, you'd get $1,221 even. Daily, you could compound it daily, you'd get $1,221.39. Now look, you went from monthly every 30 days or so to every day. How much more did you get after after 5 years? 39 extra cents, right? Could you do it more often than daily? Well, sure, you could do it hourly. If you did it hourly, you'd get $1,221.40. Right? Could you do it minutely? You could keep doing it minutely. But look, are you ever going to get a value that's actually, look, you went from daily to hourly and you got 1 extra penny over 5 years. Right? So there's some sort of a limit here that leads to the idea of compounding continuously, right? It reminds you of Office Space, right? You could compound continuously, okay? As it turns out, if you compound continuously, you don't get much of a change from like the hourly or minutely or whatever, right? What happens is you end up getting this coming out of that equation there, okay? You get 1 plus 1 over n raised to the n, okay? Don't worry about, like, if you do this where you get smaller and smaller numbers for the number of times per year, okay, then you end up with this formula. Well, it turns out that as n goes to infinity, like as n gets really, 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 really big, okay, this becomes E. Remember we talked about that number E a couple of weeks ago?
Yes.
that actually becomes e. So this number, as you get all the way up to infinity, this in calculus class, whenever you guys take calculus class, this is called the limit as n goes to infinity of this number is the definition of e. Which is kind of cool. And remember, e was like 2.7182818 dot, 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 dot. The irrational number e. Okay? There is, let's see, is there a formula on there? I thought there was. Nope, I guess not. I guess you don't have to actually use e in there. But if you said something about compounding continuously, I did think it was on there. Oh, guess not. If you did do compounding continuously, you would use this value e. I'm not going to ask you any specific questions about that. Okay, but just wanted you to see that there is some sort of a limit here. You can't get more and more and more and more money just because you're compounding smaller and smaller amounts of time. There is an actual limit there. Okay? And in fact, the formula ends up becoming the future value equals the principal times e raised to the rate times the time. Okay? That's just the way it works out. This is actually used for, this type of formula is used for lots of things. Ever hear of the half-life of something? The half-life of a value? Things like same sort of idea, using these sort of equations in there. Gives you the half-lives of things. Okay? All right. Okay. Remember how we did with simple interest, where we said, how much do we need to invest now in order to find out, to get a certain amount later? Let's do an example with that. Okay. All right. The formula that we had, okay, the formula that we had, the future value equals p times 1 plus the rate over the number of times per year times the number of times per year, or raised to the number of times per year times the time. If we rearrange that to solve for the amount you start with, all you do is divide by this whole side over here. Okay? So really what you've got is your principal now is the future value divided by 1 plus the rate over the number of times per year raised to the number of times per year times the time. Is that formula on your formula sheet? It is. It's called the future value for compound interest. So let's say, and this is the kind of thing this is the kind of thing you want to be thinking about if you are investing for the future, like that thrift savings plan or whatever, right? If you're putting money in that every month, well, your money hopefully is being compounded because it's in like mutual funds and all that. And what happens is anytime the mutual fund like gains value and actually pays back out to you, what they do is they roll that back into your fund. So it's like a compounding effect. And you can kind of guess what's going to be over so many years, like 5% or something like that. Not always true. Ask people over the last 3 or 4 years, because it hasn't been doing so well, although recently it's been doing better. But these are the kinds of questions you want to ask. So for instance, let's say you want to have $20,000, okay, in 10 years. Okay? So you want to have $20,000 in 10 years. And all you're going to do is you're going to smack down some money now and forget about it for 10 years. Okay? If you get 6% interest compounded daily, how much do you need to put down? Well, it's this exact formula. I'll write it up here. Future value, $20,000. 1 plus the rate we said was 6%. That'd be nice. 0.06 divided by the number of times per year. So if we're doing it daily, 365. That part raised to the 365 times 10. We're going to have to, again, do this on your calculators, which gets a little tricky, but do it. By the way, you can do this in parts. You don't have to do it all at once on your calculator. You can, like Tony said, you can do this one. You can do the exponent first, write that number down. You can do this part, And then you can raise that whole thing to the exponent you just wrote down. And then you can do 20,000 divided by that number. Of course, you can do it all at once if you remember how to use your parentheses, right? Did you guys get that? No? Uh-oh. What'd you get? 19,000. That would be terrible. If you put down $19,000 and then like 10 years later all you had was 20,000, you'd be like, oh man, that would be terrible. But you can use the sanity check on some of these, right? You can say, that doesn't make sense. Try it again if you get a number like that, right? But look at what this tells us about compound interest and how awesome it is. 6% interest, if you somehow got that, and if you're a good investor or whatever, if you do mutual funds, you can generally, well, 6 is still high, but you can do all right, 6% interest, right? 6% interest, you're not going to compound it daily necessarily, but 6% interest, $10,976, 10 years later, boom, you have $20,000. All that work you got, or all that extra money, basically for free. You just couldn't touch it for 10 years, right? That's the beauty of compound interest. Of course, then you have to worry about inflation rates and all that other stuff that makes your money worth less. But anyway, you're not getting it. Here's what I would do for this one.
Okay.
First of all, I would say, what's 365 times 10?
Oh shit.
3650.
That's what I did wrong.
All right? Well, let's just go through what I would do. For those of you who didn't get this number, I would do that first. I would say that's 3,650. Why not? Then I would do this. I would say 1 plus 0.06 divided by 365. 1 plus 0.06 divided by 365. And I would get a number, and it's 1 and a lot of zeros after it. OK? Then I would raise that number, in other words, the caret, to 3650. OK? And what I would get is this. I'd get 1.822022895. And I'd write that down. Or I'd do something fancy on my calculator. That is stored in your calculator right now as the little answer, ANS. What I would then do is I would say 20,000 divided by ANS. Or, in some calculators like this one, second ANS, because that gives us what I did last time. Or, instead of that, I would type in 1.822022895. You got to type all the numbers here, because sometimes it doesn't come out right if you don't type enough numbers. Anyway, I would do that, and then I would get this number. This number. You want to do it together?
Yes.
All right. You ready?
Yes.
1 plus 0.06 divided by 365. Enter. OK? Got some 1.00000 blah, blah, blah. Caret. 3650. Enter. OK? 20,000. Try this. Just type 20,000 divided by the little either answer button or second ANS. It's way at the bottom underneath the parentheses, or above the parentheses. Equals. Ta-da. Did you get that, Robert? Did you get that, guys? Yeah, fancy. These calculators are pretty powerful, right? They let you do lots and lots of stuff. And if you learn how to use them, it makes your job a lot easier when you're doing it. And, by the way, I let you use them on the test. So, hey, that's great. OK? OK. So let's do one other thing here. There's another thing called the effective annual yield. here's what this means. The effective annual yield. What this means, okay, is the simple interest rate that gives you the same result as the compound rate you just used. Okay? So you can compare things. So you can say, let's say 3.25% compounded monthly versus 3.5% compounded annually. Okay, if you don't know which one, let's say your shady car dealer is saying, I'm going to give you either 3.25% compounded monthly. And then he says, or you could get 3.5% compounded annually. But why would you want to do that? This is actually a lower rate or something like that. You're going to go, well, wait a minute. Let me calculate this out, right? And figure out what it actually is.
Let me pull out my scientific calculator.
You know what?
1 second.
Okay, so Michael's like laughing at this. He's like, let me pull out my scientific calculator. Look, when you're talking about money, don't you want the most information you can ever have, right? Yeah, if you go to the, see, this is why you do everything online. Because don't go and sit with some car dealer who's going to do magic numbers all around, right? Go online, look at the rates, try to figure it out, call up USAA if you got them, which you should, right? Figure out the right rates, blah, blah. We talked about this the other day. Figure out, and do your research is really what it is. So maybe you're not going to pull out the calculator right then, but really doing your research is what it's all about. And you might be able to do this sort of thing. Okay? All right. Okay, so on your formula sheet, do you have an annual yield called effective simple interest rate? Okay? It is a formula that looks like this. Y equals 1 plus the rate divided by the number of times per year compounded, raised just to the number of times per year, minus 1. Okay? What's that? Why'd you do the plus 1? Because this is in parentheses. Then you got to do the minus 1 outside parentheses.
You hear way too much.
What's that?
I said you hear way too much.
I hear too much. All right. Yeah, well, I pay attention. Okay, so anyway, this is how you're going to calculate the thing. So let's look at instead of 3.25, for some reason in my notes I've got 3.25 compounded monthly or 3.4 compounded. Did you already do this one? 3.4 compounded annually. Okay, I know it used to be 5. Now we're going to do 3.4. Okay, all right. So let's see. So all we're going to do is we're going to plug both of these in here and compare them. So I'll call this yield of 3.25. Okay, well, I shouldn't write it like that. I'll just do it for the 3.25 case, like this. 3.25 case. Our yield, our effective annual yield, is going to be 1 plus the rate, which is 3.25, so 0.0325, divided by, we're doing it monthly, which is 12 times per year, raised to the 12, and then after you do all that, subtract 1. Okay. And that should give you a number in percent form. Easiest way to do this is to put a parenthesis straight off the bat. Open parenthesis straight off the bat. 1 plus 0.0325 divided by 12, end parenthesis, raised to the 12 equals minus 1. I'm going to round. I got 3.3%. Lots of 1s on this one. For the 3.4, do the same thing. Parentheses 1 plus 0.034 divided by 1 raised to the 1 minus 1 gives you 0.034. Really what happened here was all these 1s and 1s, everything canceled kind of out because compounding yearly is the same as a year interest rate, which is 3.4% interest rate. Well, it's not quite the same actually. Yeah, 3 point in the end, which one's better? It depends what you're doing with it. If you're actually borrowing money, you want a lower effective interest rate, correct? That makes sense? Because you want to have to pay back less money in the end. So in this case, the 3.25 is a better interest rate. Turns out it's close. Yeah. Yeah.
The first thing you ask is like, what do you want your monthly payments to be? 0. What do you think?
Yeah. OK, any questions on all that? This is how you'd compare it. Yeah, Tony.
I am not getting this answer that you got up there.
For which one?
For this first one?
This one?
Yeah.
OK.
I'm getting like 36.
OK, get your calculator.
I got it.
OK. First, open parentheses. 1 plus
0.0325.
Good. 0.0325 divided by 12. Good. Keep going, keep going. You'll get it right. Keep going.
Close parentheses.
Close parentheses.
The little
Caret, yep, raised to the 12th.
to the 12.
Equals, yep. OK.
Am I going equal or am I
It actually doesn't matter in this case.
They subtract 1.
OK. Did you get the right answer now? Yeah.
Doesn't matter? No, it matters.
In this case, it doesn't matter. Because once you do the caret to the 12, if you do minus 1, it knows to do this part before doing the minus. Your calculator knows. You got a different answer? I'm not sure why you would have got a different answer for that.
I missed a 0.
Oh, that'll do it.
Yeah.
That will do it. OK. All right. Let's press on with a couple other things here. Actually, that was a long time at once, wasn't it?
Yeah, I got it.
OK, we have to do 2 more sections right after break. Come back at 10 of. This next section is on what we call annuities. OK? Annuities is like what your thrift savings plan is. OK? It's a number of equal payments made at equal time periods. Like on your LES, it's every 15 days. Right? You do a payment of the same amount every 15 days for however long you invest the money for. OK? It's called an annuity. And what you do is the value of it is the sum of the deposits plus the interest. OK? So an annuity is the sum of deposits. I spelled that wrong. Depositus. The deposits plus the interest. Okay? And anytime you have payments that are regular, this is what it's called, an annuity. Okay? We also have regular payments for things like mortgages or loans, but we'll get to that in the other way. This is the good kind of like monthly payments, right? Where you're going to put money away and it's gaining interest, and then eventually you get to retire or whatever, right? Okay? The formula for an annuity is also on your sheet. Okay? And it's, where is it here? It is the future value of an annuity. And P in this case is not the principal, but it's the amount of each deposit. What? No, it's pretty much the same, but watch. So this is the formula. I will write this down, and it's one of the big ones. Okay? Watch what this formula is. Okay? I will not derive it, but watch what this formula is. Okay? The future value is the payment amount times, and you have to use brackets for this one because there's lots of stuff going on here, 1 plus the rate divided by the number of payments per year, okay, raised to the number of payments per year times the time. We've seen that before. Minus 1, we've seen that before. Okay, that one was the annual effective yield, right? Okay, divided by, okay, the rate divided by the number of times per year. Okay, I know this looks like a big thing, and it is. This is another one where you do it in parts. Don't try to do it all at once in your calculator unless you practice a lot. Okay. Okay. Let's do an example of this. Okay. If, there's no H.
A.
The A is the future value.
Yeah, but don't you multiply that by the R over N?
Nope.
Oh, never mind. I'm in the wrong one.
Yeah, you're looking at the wrong. That's all right. That's okay. Yeah, you're looking at mortgage payments. Right now we're doing annuities, which are the good kind, where you get your money at the end. Okay. So if you deposit P at the end of some compounding period for an annual rate R, okay, number of payments and for some total amount of years, this is the formula we're going to use. Okay. All right. Let's do an example. $300. $300. Okay. Invested at the end of each month. This is normally the way you do it. End of the month, except for TSP, which you do at the end of the month and at the middle of the month. Okay, end of the month at 2%. That's the little at sign. 2% annual interest. Annual interest. Okay, compounded monthly. Compounded monthly. Okay, for 20 years. 20 years. Okay, find the future value. Okay, now let's think about what this actually means. You're going to take $300 every month for the next 20 years. You're going to put it in an account. Let's find out how much that's actually going to be worth. Okay, any just guesses? Just off the top of your head, guesses what that might be worth? No fear, no, you can't cheat. Okay, how much? Just guess. 600, $600,000? $60,000? Okay, we got a guess of $60,000. That's a lot of money. Any other guesses? Okay, I didn't hear that guess because you cheated. Any other guesses? Okay, let's see how much it is. Okay, I like the $60,000 guess. That's a pretty good guess. $300 a month. You know, how hard is it to afford $300 a month? Now, if you have kids and you've got house payments and all, I mean, it's hard. But, you know, well, no, yeah, no kidding. I mean, if you're not making that much money, but $300 a month, you know, I mean, if you can scrape up and you can say, look, I'm going to do this for 20 years. Let's find out what happens. Okay, P is the payment amount, which is $300. Okay. Bracket, I better put this here so it's not the same. Okay, bracket, 1 plus, the rate in this case is 2%. That's actually not that much. 0.02 divided by the number of times per year, monthly, so we've got 12. That whole thing raised to the number of times per year times the time, which is 20 years, minus 1. The whole thing divided by the rate, which was 0.02 divided by the number of times per year, which is 12. Okay, you got to do this one. I would do this one piece by piece. I don't even think I'd trust myself to do it all at once. Okay? 0.02 because it's 2%. Okay. All right. Okay, I'll start to do this, and then if you guys, well, we'll get an answer. 300 times. It is a lot of parentheses. Multiply it. Okay. No, I won't tell you yet. I'll start writing some of these things down. Well, actually, I won't quite. I'll do it in piece by piece. Now you guys got? I know that's what Aaron got. Okay. Here's how I would do it. If you guys aren't getting this number, that's okay. Here's what I would do first. Let's look at this piece by piece. First, do this inside piece here. 1 plus 0.02 divided by 12. 1 plus 0.02 divided by 12 equals, and you get some number, 1.000 something. Okay? Raise that to the, in parentheses, 12 times 20. 12 times, or 240. Okay? And you get a number like 1.49 something? Oh, okay, hold on. Let's do this again. Just right now do this. 1 plus 0.02 divided by 12 equals. Okay. Caret. Yeah, equals. Okay, then do the caret. 240 equals. Subtract 1, you get 0.49 something? Okay. Divided by, hold on, divided by, now this is where it gets a little tricky. This part definitely has to be in parentheses. So divided by, open parentheses, 0.02 divided by 12, close parentheses. Whoop, what did I do wrong? Point. Oh, no, I forgot to multiply by 300. You're right. That's okay. You can actually do it at the end. You can actually do it at the end. It's okay. Yeah. It doesn't, in this case, it doesn't actually matter. So yeah, whatever that number is, I'll back up. Divided by 300 times 0.02 divided by 12. Okay, you can do it at the end if you want. So you get 0.49, and then you multiply by 300, and then you divide by parentheses 0.02 divided by 12. Okay. Yeah, Aaron.
What's the rule? Why do you have to put that bottom part in parentheses?
Okay, what this means is this whole thing divided by this division, right? So what this is it's this divided by this. So what it really is this times 12 divided by 0.02, because this gets flipped when you're dividing. So really what you have to do is this whole thing first. And if you're dividing, but you do that first, and you can divide at one little part. Okay? All right, let's try it again. Okay, I will try not to mislead you this time. You got it? We'll do it one more time here. You guys ready? Okay. 1 plus 0.02 divided by 12.
1 plus
0.02 divided by 12. Okay. I'll check my own answer here. 1 plus 0.02 divided by 12. You get 1.001666667. Okay. Caret. Parentheses. 12 times 20. End parentheses. Okay. Okay. Enter. Does everybody have 1.4913?
Yes, sir. I do.
Robert, you got that? Uh-oh. You might have done you forgot the open parentheses here and close parentheses there. That might have been what you did. Okay, we're going to keep going. minus 1. So you get 0.49 whatever, right? Times 300, because you got to do this one. And you got 147.39 something something. OK. Divided by, open parentheses, 0.02 divided by 12, close parentheses, enter. $88,439.
Okay. What the hell? I thought I did that.
OK. Try it at home. You're going to have to do it on the homework. Now, again, let's go back to the whole point of all this. If you can scrape up $300 a month, it is a lot of money actually. If you can find $300 a month to put in your TSP, and you do it for 20 years, even if you made a pretty terrible 2% interest, ta-da, 88 grand in the bank at the end.
Wow.
Right?
You're certain.
OK. Yeah, TSP is a big deal. If you can afford it, it just makes sense. Or whatever. Yeah. Yeah, I mean, you should just, just know that this compound interest business is a huge, huge deal. OK? All right. OK. OK, let's see. That was the future value. OK. Let's see. Do we have the monthly? Yeah. OK. The next formula on your sheet is how much you need to invest. The next formula on your sheet is how much you need to invest in order to get a certain amount of money by the end of some amount of years. And it's as an annuity, so you invest over time. OK? So let's look at this one. Again, it's a little bit crazy. But it's very similar to the ones we've been doing so far. The amount you do per month now equals the annuity amount that you want at the end, the future value that you want at the end, times the rate divided by the number of times per year, all that divided by, OK, in brackets, 1 plus the rate divided by the number of times per year, raised to the number of times per year times the number of years, minus 1, end bracket, and you're done. OK? How much do you need to invest at the end of each month in an annuity earning 3% interest compounded monthly, I'll write this down, in order to have $150,000 after 10 years? 10 years now. OK, you ready? Here's the question. You want to invest, let's see, you want to invest at 3% interest, OK, compounded monthly, to have $150,000, OK, after 10 years. 10 years. OK? I think we have all the numbers here. Try plugging it into this new one here and then solving it.
How do you save your answer again?
The ANS button will give you the answer back in a calculation.
So if I push it there, I won't lose all that.
Yep. Here's what I'm going to do. I'm going to start writing it like this. 12 times 10 years minus 1. Okay. that what you got, Sharifa? What's it? Uh-oh. Forgot a 0?
Is that the answer right now?
This is the answer. Per month. All right. So for you guys who aren't getting this in your calculator, are you at least writing it down right? That's the first question.
I written it down exactly.
Okay, good. That will get you lots of points.
Okay, so
I'm just saying that when you type it in, okay, you're gonna. The problem is you're just not learning. You don't know how to use your calculator yet.
okay, so if I multiply 150,000
Yep.
by this point 03 divided by 12, I
Yep.
get 375.
Yeah, you do.
Okay,
So let's do this.
So then-
Write that down.
so then I put my 375 off to the side. 'cause
Yep.
that's what I got for that stuff.
Okay, good.
All right, then I do my 1 plus
1 plus
0.03
0.03 divided by 12.
divided by 12.
Okay.
Right? And then I do the little carrot.
So did you do that in parentheses?
Then I do what in parentheses?
This 1 plus 0.03 divided by 12? How's that go again? Nadia?
No, I didn't.
Okay, so you got that number, right? And you raised it to the 120?
Close parentheses, right? And then I raise it 120.
Good. What'd you
Then I
get?
subtract 1.
Hold on, what'd you get?
Before I subtract 1?
Yeah, before you subtract 1.
1.34935347.
Good, okay. Now you subtract 1. Okay.
Okay, I got that.
All right. Now you can do one of two things. You can either,
Multiply.
no, it's gonna be divided by. So you're gonna do 0.3493535547. And now you're gonna do 375 divided by that number. On your calculator, there is an easy way to do that. You do, you just type 375 divided by the answer button, because that gives you the last answer. And you'll get 1,073. You got to practice this. Okay? Okay. Dominic, you getting these?
I didn't get this.
Okay. You got to walk through all the steps. And the way Tony did was very good. He said, I'll do the top first, write it down. I'll do the bottom first in steps. This part, and then do raise to the 120 equals, then do minus 1. Write that down, or use your answer button in your calculator and do 375 divided by that. And you'll get the right answer. Okay? All right. Okay, one last topic for the night. Okay, one last topic. We're going to start talking about mortgages. Okay? All right. Okay. Okay. This is actually called installment loans, amortization, and credit cards, but really, we're going to talk about mortgages. Okay? A lender gives you P dollars. Okay? So some lender says this, look, I'm going to give you P dollars, some principal amount, for a mortgage, for your house, to buy your house. Okay? At the end, they want this much money. They want P times 1 plus R over N to the NT, because they're going to ask for compound interest. That's all that is. That's compound interest. Okay? They're actually going to give you P dollars, and they're going to ask for the final value of that amount at the end. Okay? But what they do is they don't say, come back in 30 years and give us that amount of money, right? Because they want to get the money while it's going along. Okay? So you have to pay monthly payments. Okay? You have a monthly payment formula on your sheet, which is kind of similar to the other ones that we've done, except this time it's not you're gaining all this money. This is how much you're paying out to the bank every month. Okay? Here's what it looks like. The actual final value for this is some payment, PMT, although on your, does it say that on here? Yeah, it is. Oh, actually, you know what? I'm not gonna actually derive this whole thing, I'm going to give you the formula for the payment. It's on your sheet, and we're going to do that so that we don't have to take too much time to do the deriving of this. If you want to see how it's derived, look at the notes that I give you online. OK, the payment amount is this formula, and it's relatively similar to the one we've had before. OK, what you're basically doing to derive it is plugging in all these parts of the pieces that we've already got, and then you end up spitting out the payment. So here's what it is. The payment amount for your mortgage equals the principal times the rate divided by the number of times per year you're going to pay this, just like always, divided by 1 minus, in parentheses, 1 plus the rate divided by the number of times per year to the negative nt. OK? This negative part is important. Do this whole thing in parentheses. I could rewrite it like this. Parentheses there, parentheses there. Negative number of payments per year times the number of years. OK? The reason it does that is the algebra that you have to do to get there. OK? All right. Let's try one. You ready for this one? You want to borrow $15,000 for a new car. OK? This is like a mortgage, just a new car. It's a car payment. OK? $15,000 for a new car. That'd be a pretty cheap new car, I guess, these days. OK? $15,000 for a new car. You can either take loan A, which is 4 years at 3% interest, or you can take loan B, which is 5 years at 4% interest. Okay? And we're going to compare
So we can choose either
the two
one?
payments. You can choose. Okay? You have to do both to figure out which one's better. Okay. So let's figure out your payment here. Okay? Let's figure out your payment. OK. For loan A, here's your payment. OK? Your payment equals principal, which is $15,000, times the rate, which is 0.03, divided by, you're still doing monthly payments. OK? Yeah, these are monthly payments. OK? Divided by 1 minus, parentheses, 1 plus 0.03 divided by 12 to the negative, I'll put that in parentheses, negative n, which is 12 times 4 years. 4 years. OK. Let's do that out. Remember, the negative button is not the minus button. Should probably put the 0.01. Dwan, did you get the right answer to this one? No. You guys need to learn how to use these little calculators. Yeah, Robert.
I say negative 12 times 4.
Negative 12 times 4, yeah, because it's negative nt. Good. Okay, hopefully you guys are getting out values like $332.01 per month. Okay. I'll wait till you get these ones done. You trying to do it all at once? Uh-oh. Okay. Did you get 332? 01? Yes, I like to see that. You guys in the back corner get it? You want to try it? Let's try it all just together. Ready? Okay. First things first. 15,000 times 0.03 divided by 12. Should give you 37.5 maybe? Okay. Set that number aside. Write it down somewhere. 37.5. The bottom. Let's do this part first. 1 plus 0.03 divided by 12. 1 plus 0.03 divided by 12 gives you 1.0025. OK. Do the caret button. Now, this is where you need to be really careful. Put a open parentheses. Type the negative button, which is the little one way down at the bottom and down at the bottom there. Looks like a minus, but it's in parentheses, right? Negative 12 times 4. Then do an end parentheses. You should get something like 0.88705. OK. Now what you've done is you've got this part. You need to subtract that from 1. So do this. 1 minus, and then the answer button. Second, and then the little negative sign again, because that gives you the answer. OK? Did you get 0.1129? OK. So what you do now is you do this number divided by that. So you do 37.5 divided by second answer again, because that's what you just got. And you should get $332.01. OK? All right. Now, that was loan A. Did you get that one, Dominic?
The answer button is talking about.
OK, the answer button. You hit the second and then the answer button. Second button first, then you hit the little negative sign at the bottom.
Oh, okay.
You got it? That's the answer button. OK, good. All right, now let's look at loan B. OK, I'm just going to erase this and do loan B right here too. I wrote down the number here, $332. OK, loan B, same thing. Principal, still $15,000 times 0.04 divided by 12. OK? The whole thing divided by 1 minus 1 plus 0.04 divided by 12 to the negative. Now it's going to be 12 times 5 years. OK? Let's see what you get.
Oh, dang it. I don't know what to do.
Another one.
Is it 276.24?
It is.
It is?
Yeah, 2.5 I would round up, but 2.5, good job.
Oh, that's 2 out of 5.
All right, now you're getting the hang of it.
I would say.
Did you get that one? Why not?
Like 40.
Try again. First, do this. 15,000 times 0.04 divided by 12. You got 50, right? OK, so you write that down somewhere. OK. Then you do this part. 1 plus 0.04 divided by 12 equals 1.0333333333. OK. Raised to this, so you do the caret. No. Yes, raised to negative 60. When you got 0.81900, blah, blah, blah. OK. Now you need to do 1 minus that. So you do 1 minus and then second in the answer button. 0.18. Now you need to do this number divided by that. So you do 50 divided by second answer. 276. See how that works? OK, yeah, Dave.
So this is telling you your monthly payment for the span of the loan.
Yeah, good point.
However,
Yes. Go ahead. However,
one's cheaper per month, but the other one is
yeah. OK. Dave is bringing up a very good point now. Did everyone get hopefully $276.25 eventually? OK. Which loan's the better loan? And Dave's got a good answer here. But which loan's the better loan? A or B?
B.
Somebody says A, somebody says B.
Oh, no, yeah, it is B.
Why?
A.
Why is it A?
It's A.
Why?
Because it's less years.
OK. Let's figure out how much it's going to cost you. Very good question. This is exactly what Dave was alluding to, I assume. OK. Let's look. So you look at this and you say, and this is, by the way, this is exactly what those car dealers do to you. They say, hey, look, your loan is now going to be $276 a month. Wow, that's much better than $332 a month. But loan A costs you, in the end, how much? It costs you $332.01 times 12 months times 4 years, which is how much money? $15,936.48. OK. And by the way, you borrowed $15,000. So this is costing you $936, right? OK. All right. The other loan, loan B. Let's see how much that one's worth. That one costs you. It's $276.25 per month times 12 months times 5 years. 276.25 times 12 times 5 years, $16,575 even. Which one's the better loan? A is the much better loan. In fact, minus $15,936.48. If you listen to the car dealer, you will spend $638 more on loan 2 than loan B than loan A, right? Because you spent 5 years paying it off. Even though you have much lower payment, you're doing it for so much longer that it ends up being a worse deal. Now, what does that mean? Sometimes you can't afford the higher monthly payment, right? So you got to go with a lower monthly payment, but you got to make those decisions. Okay, but don't just think that because it's a lower monthly payment, it's better. Okay, all right. Last one. This is going to be the mortgage one. Okay, and remember I talked about points before. This is where we're going to take this into consideration. Okay, all right. It's the same formula here for car loans and mortgages. Okay, here's your house. Okay. Your house costs $112,000, which, if you live in Boston, you would not get a house for $112,000. You would never get a house there that much. Maybe if you live in Indiana or something, you might, right? Because places, less expensive. Let's say you have to pay 6% interest. Now, if you had a 6% interest rate today, you got screwed by your bank, because you should be getting a loan of like what, 3% by now, 3.5%, 4%. Something like that. But let's say you got 6% interest. Okay, you take out a loan for 30 years. Okay, you pay 2 points, and I'll talk about what that means in a minute. Okay, you pay 2 points on this, and you have a 10%. What do you normally pay when you're buying a house? A down payment. Okay, 10% down payment. Okay, so we have to calculate this out. Now, this is going to be kind of a long thing here. What we're trying to do is we're trying to find the monthly payment. Monthly payment. That's the first thing we want to find. And the second thing we want to find is the total price we're paying for this house. Okay. Total price, does that include the down payment? Sure it does, right? You're paying that money up front. No, you're not, okay? It also includes the points that we're going to talk about here, okay? All right, here's how you would do this. First things first. You wouldn't worry about this one yet, because you got to like do your down payment and your points first. Okay, first thing you do with your loan is you pay the down payment straight off the top, okay? So you're going to have $112,000 minus your down payment. Your down payment was 10%, so you do 0.1 times $112,000. Okay? That gives you the amount you have to be mortgaged, the amount you actually have to mortgage, which is $100,800. Okay? Now, points, okay, is this idea of paying some of that interest up front. What it normally means is if you're going to pay points, it means you're going to get a lower interest rate than you would by not paying points. Okay? 1 point is worth 1% of your loan. Okay, it's an easy one to remember. 2%, 2 points is worth 2% of your loan. Okay? So if you're doing 2 points, okay, for the points you need to do 0.1, which is, 0.01, which is 1%, times 2 points times the amount you have to mortgage. It's not off the top, it's the amount after your down payment. Okay? This actually gives you $2,016. Okay? $2,016. You have to pay that, right? That's what you have to pay straight off the bat as well. Down payment plus that amount. This doesn't take anything else off the mortgage amount, which is unfortunate, but it doesn't. Okay? But you just have to pay that. Okay? The reason you're paying that is because you got a lower interest rate than you would have otherwise, even though it's 6% interest. Now what you want to do is you figure out your payment. Okay? Let me do this. I'll sneak it in down here. Your payment is the exact same thing that we did with the car loans. Okay? The principal. In this case, it is $100,800 times 0.06 divided by 12, because you're doing monthly payments, divided by 1 minus parentheses 1 plus 0.06 divided by 12 raised to the negative 12 times 30 years. That's a long time. Okay? All right. Now you got to do this number to figure out your payment.
So is the 1,800 is in parentheses, or we just you just put it there?
I just put it in parentheses because it's being multiplied by. You don't have to do that on your calculator. Okay? Yep.
So the points don't have nothing to do with that at all.
The points is just how much extra you're paying on top of the down payment.
But it's not taken away from
It doesn't take anything else away from this, no.
So if we didn't put the points in there just now, it would be the same answer.
Same answer. Yep. But when you do the total cost, you got to take that into consideration because you paid that off as well, right? Okay, 604.35 is what I got and what Michael confirms, or he got and I confirm. Okay. That's not bad. Payment per month for your house. The point of points is that the other, if you didn't pay the points, the bank would say you have to pay 6.25% instead of 6%.
So you're trying to knock some of your interest rate down?
Yes. And you're trying to knock some of your interest rate down by doing the points. What you can do, and if you look in the book, they talk about how you might do this. You can compare whether or not it's worth doing the points. Because you can always, like the bank's like, fine, we'll take as many points as you want to pay right now. Because basically it's like interest off the top for them. They just give you a lower interest rate to do it later. And what that does for you is it says you get a lower interest rate. So if you have a long enough loan, you make more money than you would have if you don't pay as much in the end. And so you just have to figure out that balance point where that much is less than the amount of interest you're paying over time. Yeah.
So explain the points thing again.
Okay.
1 point is worth what now?
1%. 1 point is worth 1%. So 2 points is 2%.
So we would just go, so say if we had one with like 5 points, it'd just be 0.05.
Yes, times the amount you need to mortgage. Yep. That's it.
So how
Times.
did you get the 1?
I just said 1 times 2.
So
Like
then it would
1%.
be 0.01 times 5.
Yeah,
right?
which is 0.05.
Oh, okay.
Yeah. So I just did it out a little bit. Okay. Now, the payment's $604.35, but we have to figure out what the total cost, total price of your house was. Okay, I'm going to do this right up here. Okay. You have to consider everything that you paid. Okay. So the total cost. You've got your down payment of what did we say? Down payment was 10%. Oh, so it's, sorry, is it 10%? Yeah, it was 10%. So $11,200. $11,200 plus, right? Plus the points, because you did pay that money, $2,016. Plus, this is the points. Now, you pay this amount, $604.35, for 30 years, every month. $604.35 times 12 times 30. Okay? Well, equals don't buy a house, yeah. Well, hopefully the house is worth more, but of course you also have to pay taxes.
They're going up finally now.
Really? That's good.
2 years ago again for investment, I was like, that was done.
Yeah.
I got about 23 grand over.
Really? That's not bad. Okay.
23 grand,
That's good. If you can get you can pay off, or if you can get a house that's worth more these days, that's great. So here's what I have. Hopefully you guys got roughly the same number. $230,782. Okay? That is a lot of money. Okay? So what that means is if you buy a house today, right, for $112,000, it's like you bought it twice. But, okay, so A, there are taxes you have to pay on this, and whatever other fees you have if you live in some like community where you have to pay fees. But hopefully 30 years from now, your house is going to be worth a lot more than that. Hopefully. Okay? Yeah. But, you know, that's the idea.
So
Okay.
you're hoping the value of your house more than double.
More than doubles over 30 years, which is pretty likely. Although houses, so believe it or not, real estate is not a particularly good investment. It is a relatively safe investment long term. Like if you could end up in the bad situation where you bought 30 years ago and then tried to sell 3 years ago and you're in trouble. But, you know, if you wait another 5 years, you might be able to be okay. Yeah, question one.
The question, I don't know if this is off topic or not, but say we did $1,200 a month on payment.
Say we did $1,200 a month on payment? Good point. So the way the bank figures this out, if you're going to do $1,200 a month, what the bank says is, this is how much you owe me. The rest of it comes off the principal, whatever's left over. Now, we're not going to go into what the way the banks are, in some ways they're kind of shady. They want their interest up front, right? So what they do is, the first payment you make, $604.35, most of that, like $603 worth, is going to be interest. That means your principal, the total amount you still owe, is only going to go down by like $1, right? And then the next month, it's going to be like $2. And then the next month, it's going to be like $3. So it's going to slowly over time go up, because what they don't want you to be able to pay off the amount. But you can generally, and you should make sure you can do this in your loan if you do get one, you can double your payment. All the rest of that does take off the principal. So there's another trade-off there. You could also, if you wanted to do that, well, why aren't you just getting a 15-year loan? You know what I mean? Where you get even, a much less, a better interest rate, and you have to pay it off over a lot less time. The nice thing about doing it this way, there's kind of a couple benefits. Benefit number one, let's say you have another kid and all of a sudden you can't afford that $1,200 a month. Well, then you can go back to paying these payments. You're going to make your loan longer. The other part is that you're not like fixed, locked into that rate. And the other benefit is you can make up however much money you want on the end if you can afford it every month. So it's a trade-off. You just have to be more willing to do that because it's really easy to only pay this amount every month. So yeah, Tony.
I got a question.
Yeah.
What if we had it to where you don't have those 2 points? And what would you do differently?
The only thing you do differently is you would just not add those points in. That's all you do differently. But what would happen in real life is you wouldn't get 6% interest. You'd get 6.2% interest or something like that. The points means you're going to get a better interest rate. That's all it means. Okay? I think normally 1 point is worth 0.125% or something like that. The banks do that somewhat. Yeah.
How much freedom do the banks would have to change the value of a point? Is that naturally regulated?
I think a point is considered 1%. Yeah, I think that's what they.
They can't just be like, hey, yeah, 1 point, but in their subscription they say 1 point equals.
Yeah,
2%.
they might be able to say the 1 point equals 2%, but I think 1 point is defined as 1% in the banking world. It's just a convention. Yeah, banks are very much regulated, but you still have to read all the fine print. Just like joining the Army, don't sign anything until you've read it, right? Or you've got your lawyer to read it or whatever.
Don't sign
yeah.
it.
Yeah, or just don't sign anything, go in a different branch. Okay, all right, we're done with the learning for tonight. I've got a number of things I want to hand out to you because I forget who it was that asked me the other day. Was it Santos? You wanted the final early? Yeah. The first thing I'm going to give you is the final exam practice. You cannot do all the questions in this, but we just looked at it. You can do like 70% of them already. I'm giving you this now. Please don't lose it because I'll only make a couple copies later. But I want you to have the practice final now. I will give you another practice final, which hopefully has different questions on it. What happens is the guy who runs the course for the whole world, who does this for UMUC, gives out the practice final and the real final. It may be the same exact one, but hopefully it'll be different. If not, I'll make up some other questions that are different. But I want you to have it now. The answers are already on there. You can start looking at it. This is what the final is going to look like. Lots of word problems. Lots of problems that take a lot of calculation. There's only 20 questions, but they're long questions.
He gives us 2.5 hours to do it.
You get 2.5 hours to do it. Okay? And as with any other one, I'll give you more time if you need it. But yeah. Well, here's the other thing. Next week we do have another quiz, but it's not on this. I will give you that paper tomorrow. The practice for that tomorrow.
What is that quiz on?
It's on most of the stuff we've been doing up to this point. Actually, I think we might have covered it all already, but that's it. Okay, there are 2 more handouts. Okay, 2 more handouts. One is on the 8.234 that we did earlier tonight. The other one is on 8.5 and then some stuff we're doing tomorrow, so you don't need to worry about that, but there you go.